In today's lecture, we are going to learn how we can do the analysis of space complexity in an algorithm. So I am taking one simple example of factorial. How we can calculate factorial space complexity in two ways so that you can identify that how we are doing. So first I am using non-recursive method. So this is the code has been written for factorial calculation in non-recursive manner. So it is not recursive function. So we have taken factorial function. We have taken one function type and function as a factorial. So here we are defining a value as 1 and we are taking for loop which start from 1, it will go up to n, and every time it is incrementing, and in incrementing every time it is multiplying by with the I value. Because how we calculate factorial 4? For factorial, suppose if I am calculating factorial 4, so calculating factorial 4, what is required? Factorial 3 is required, then factorial 3 calculation, factorial 2 is required, and for factorial 2 calculation, factorial 1 is required, like this. So every time it will increment the value. First value will be a value is 1, I value is 1. Then value will increment by 2 because it is incrementing plus 1. So 1 into 2, that will be 2. Like this it will go. So at the end it will calculate the factorial 4 value. I'm just giving you one example. Right. So here we are able to see how many variables are there. One variable, first variable n, second variable a, and the third variable is I. And because this is function, so I have not written for all, but all three are of integer type. All three are of integer type. So if I am supposing that integer is of 2 byte, so we can say 2 into 3 is 6 byte. If any integer is of 2 byte, because we have taken 3 variable n, a and I, and all are of integer type. So if any integer is taking 2 bytes, so 2 into 3 is 6 byte in non-recursive manner. 6 byte is just a constant number, so we can say because every time value is changing, we are not storing any value, so only one value we are taking. So if a value is changing every time, I value is also changing every time if n value is fixed. So still we are not storing any value, only these three variables we are using, and all are of integer type. So if integer type is of 2 bytes, so 2 into 3 is 6 byte maximum it is taking. So we can say order of 1. Space complexity will be order of 1 because it is an constant 6 byte. So space complexity will be order of 1 if we are using non-recursive method for calculation of factorial n. Now coming to the next, when I am taking recursive method to solve this problem. So I am writing here the code for that, entire code for that. Suppose I am writing main function, then I am writing complete code here. So integer n is equal to 4. This is of integer type, right? Then I'm writing printf fact n. After calculation, what will be the value? It will print that value. Then I am just writing the function factorial, which is of integer type. Then I am defining here variable integer a comma b. I am taking two variable here, and if n value is less than equal to 1, then simply it will return 1. Else what it will do? It will calculate the factorial like this: a is equal to factorial n minus 1, and b is equal to n into a, and it will return b. Else loop closing, integer loop closing, and this main loop closing. Right. So here what we are doing, every time you are saying it is recursive function. If it is not less than equal to 1, so what it will do, every time it will multiply a value with n value, right? And it will give us the solution at the end. So how we are doing, just see, take a call. Suppose in the similar way as we have calculated factorial 4 for non-recursive, I am taking the same value. So for factorial 4 calculation, what is required? Factorial 3 is required. For factorial 3 calculation, factorial 2 is required. For factorial 2 calculation, factorial 1 is required. Right? So here what value we have stored? 4, 3, 2, 1. Right? And we know factorial 1 value is what? 1. So its total value is 1. So now when we reach to the base, because in recursive what we do, we just call function again and again and again until unless we will not reach to the base condition, or we can say the termination condition. So a factorial 1 value is the termination condition, base condition, because we know its value, as you can see here written 1. So we will take 1, then we will take this value and we will go to here. So again 2 into 1 is 2, right? Then this value is 2, so now we will take value 2. So 3 into 2 is equal to 6. Now we will take this value 6. 6 into 4 is equal to 24. So factorial 4 value is 24. So at the end we will reach to that value. What is the value of factorial 4, right? So what we are doing here, see here carefully. When we are calling a function, every time we are storing the value of these 3 variables. What 3 variables we are having here in this function? N, A and B. What 3 variables we are having? N, A and B. These 3 variables we are having, and all of integer type. So if integer is of 2 bytes, so again 2 into 3, that is 6 byte. That is 6 byte. But here, because we are calling recursive function, so once we have called factorial 4, so we need to store those values of N, A and B. We need to store those values. See here in this. For factorial 4, we are going to factorial 3, we are going to factorial 2, factorial 2, we are going to factorial 1. This is the termination condition from, and here what we are storing in factorial 4, 4, factorial 3, 3, factorial 2, 2, factorial 1, 1. But termination condition, its value is 1, so we are multiplying it by 1 because N into A, right? So we are getting 1, then we are going again. 2 into 1, 2, then 3 into 2, 6, then 4 into 6 is 24. So we are taking the value. First we are going in downward direction, then we are going to upward direction. So what we are storing here, in every step, we are storing N value, A value and B value. So this is for 6 byte, this one. Then when we are going here, so here we have stored this N value, right? Then again N, A, B value. So again 6 byte. Then again in this, what we are doing, again we have stored value N, A and B. So again it is 6 byte. And here also N, A and B. So 6 byte. Again, right? So here N value is what? 4. What we have taken? 4. So how many times it is executed? 4 times. So we have saved the value 4 times, right? So you are able to see it, every step we are storing the value. So its space complexity will be order of N. How many times N value is 4? So it is calculating N time. 4 times. So space complexity will be order of N. In which recursive? In recursive it will be order of N. While in non-recursive, because we are not storing those values like this. In for loop, only just value, A value we are storing. So it will be only simple white, nothing else. It is not calculating up to N time. In the similar way, if we are taking factor of 4 here, so it is not storing the value. Once value is 1, then again it will be 2. So this value is gone. After this iteration, this value will not be there. Then this value will be 2. Now after this iteration, its value will be something else. So it is not storing. It is storing only one value. So its space complexity will be order of 1 in non-recursive. While in recursive, its space complexity will be order of N. So in this way, we can calculate the space complexity of any algorithm. So if you like it, share it, subscribe it. Thank you.